Welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12th Physics, Magnetism and Matter, Chapter 5 NCERT Solution Part 3. Our mission is to provide free classes on YouTube for all the students of class 6 to class 12 and special classes for the students who are preparing for IIT, JEE, NEET, NDA and other competitive examinations. Before we begin our lesson, we have a small request. Please subscribe, like and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever any video is uploaded by us. Let us begin today's lesson. So today we'll start with 5.13. A short bar magnet placed in a horizontal plane has its axis aligned along the magnetic north-south direction. Null points are found on the axis of the magnet at 14 cm from the center of the magnet. The Earth's magnetic field at the place is 0.36 G and the angle of dip is 0. What is the total magnetic field on the normal bisector of the magnet at the same distance as the null point, that is 14 centimeter from the center of the magnet? Let us see the solution. Earth's magnetic field is given by H is equal to 0.36 G. The magnetic field at a distance t on the axis of the magnet is given as B1 is equal to mu naught upon 4 pi multiplied by 2m dq is equal to H. Equation number 1. So where mu naught is permittivity of a free space, m is equal to magnetic moment. So m is equal to magnetic moment. The magnetic field at the same direction, at the same distance d on the equatorial line of the magnet is given as B2 is equal to mu naught m upon 4 pi dq is equal to h by 2 using equation 1. Total magnetic field B is equal to B1 plus B2. H is equal H plus h by 2. So putting the value of H, we get 0.36 plus 0.18. Upon solving, we get 0.54 G. Hence, the magnetic field is 0.54 G in the direction of the Earth's magnetic field. Let us see the next question. So, the next question is 5.14. If a bar magnet in exercise 5.13 is turned around 180 degree, where will the new null point be located? So let us see the solution. The magnetic field on the axis of the magnet at the distance d1 is equal to 14 centimeter can be written as b1 is equal to mu naught 2m upon 4 pi d1 whole cube is equal to h, equation number 1, where m is equal to magnetic moment, mu naught is equal to permittivity of free space, h is equal to horizontal component of magnetic field at d1. So if the bar magnet is turned through 180 degree, then the neutral point will lie on the equatorial line. Hence the magnetic field at distance d2 on the equatorial line of the magnet can be written as b2 mu naught m upon 4 pi d2 whole cube is equal to h. This is equation number 2. Equating equation 1 and equation 2, we get 2 upon d1 whole q up is equal to 1 upon d2 whole q. Upon solving, we get d2 upon d1 whole q is equal to half d2 is equal to d1 multiplied by half to the power 1 by 3. Putting the value of d1 and solving it, we get 14 multiplied by 0.794 is equal to 11.1 centimeter. The new null point will be located at 11.1 centimeter on the normal bisector. Let us see the next question. Let us see question number 5.15. A short bar magnet of magnetic moment 5.25 multiplied by 10 to the power minus 2 J per Tesla is placed with its axis perpendicular to the Earth's field direction. At what distance from the center of the magnet the resultant field is inclined at 45 degree with Earth's field on A its normal bisector and B its axis. Magnitude of the Earth's field at the place is given to be 0.42 g. Ignore the length of the magnet in comparison to the distance involved. Let us see the solution. Magnetic moment of the bar magnet M is equal to 5.25 multiplied by 10 to the power minus 2 joule per Tesla. Magnitude of Earth's magnetic field at a place H is equal to 0.42 G, which is equal to 0.42 multiplied by 10 to the power minus 4 Tesla. A. The magnetic field at a distance r from the center of the magnet on the normal bisector is given by the relation B is equal to mu naught M upon 4 pi RQ. Where mu is equal to permeability of free space, which is equal to 4 pi multiplied by 10 to the power minus 7. So 10 to the minus 7 T M A inverse. When the resultant field is inclined at 45 degree with Earth's field B is equal to H. Therefore, mu naught multiplied by M upon 4 pi RQ is equal to H is equal to 0.42 multiplied by 10 to the power minus 4. Therefore, mu naught M 4 pi RQ is equal to H is equal to 0.42 multiplied by 10 to the power minus 4. Therefore, RQ is equal to mu naught multiplied by M 0.42 multiplied by 10 to the power minus 4 multiplied by 4 pi. Upon solving, we get 12.5 10 to the power minus 5. R is equal to 0.05 meter, which is equal to 0.5, which is equal to 5 centimeter. Now let us see the solution for the part B. The magnetic field at distance r dash from the center of the magnet on its axis is given as B dash is equal to mu naught 2m upon 4 pi RQ. The resultant field is inclined at 45 degree with Earth's field, that is B dash is equal to H. Putting the value of B dash as mu naught 2m upon 4 pi r dash q is equal to H. Putting the values of mu naught m, pi and r dash, we get 4 pi multiplied by 10 to the power minus 7 multiplied by 2 multiplied by 5.25 multiplied by 10 to the minus 2 upon 4 pi multiplied by 0.42 multiplied by 10 to the minus 4. Upon solving, we get 25 multiplied multiplied by 10 to the power minus 5. Therefore, R dash is equal to 6. R dash is equal to 0.063 meter, that is 6.3 centimeter. Let us see the next question. Now let us see the additional exercise questions, that is 5.16. Answer the following question. A. Why does the paramagnetic sample display greater magnetization when cooled? Let us see the solution. So, answer to the question 5.16a, owing to the random thermal motion of molecules, the alignment of dipoles get disturbed at high temperature. On cooling, this disruption is reduced. Hence, a paramagnetic sample displays greater magnetization when cooled. Let us see the next question. Why is diamagnetism, in contrast, almost independent of temperature? Let us see the answer. So, answer to the problem B is the induced dipole moment in a diamagnetic substance is always opposite to the magnetizing fields. Hence, the internal motion of the atom, which is related to the temperature, does not affect the diamagnetism of material. Let us see the next question. Next question is C. In a toroid uses bismuth for its core, will the field in the core be slightly greater or slightly less than when the core is empty? So let us see the answer. Bismuth is a diamagnetic substance, hence the toroid with a bismuth core has a magnetic field slightly greater than of toroid whose core is empty. Let us see the next question. Question number D. Is the permeability of ferromagnetic material independent of magnetic field? If not, is it more or lower than the higher fields? Let us see the answer. The permeability of a ferromagnetic material is not independent of the applied magnetic field. It is greater for the lower field and vice versa. Let us see the next question. Next question is E. Magnetic field lines are always nearly normal to the surface of the ferromagnet at every point. Why? Let us see the answer. The permeability of a ferromagnetic material is not less than 1. It is always greater than 1. Hence, magnetic field lines are always nearly normal to the surface of such material at every point. Let us see the next question. The next question is F. Would the maximum possible magnetization of paramagnetic sample be of same order of magnitude as magnetization of ferromagnets? Let us see the solution. So, the maximum possible magnetization of paramagnetic sample can be of same order of magnitude as magnetization of the ferromagnet. This requires high magnetizing fields for saturation. Let us move to the next question. Question number 5.17. Answer the following question. A. Explain the qualitatively on the basis of domain picture the transversibility in the magnetization curve of ferromagnet. Let us see the answer. So the answer to the question A is the hysteresis curve BH curve of ferromagnetic material is as shown in the following figure. This one. It can be observed from the given curve that the magnetization persists even when the external field is removed. This reflects the irreversibility of a ferromagnet. The next question is B. The hysteresis loop of a soft iron piece has a much smaller area than that of carbon steel piece. If the material is to go through repeated cycles of magnetization, which piece will dissipate greater heat energy. Let us see the solution. The dissipated energy is directly proportional to the area of the hysteresis loop. A carbon steel piece has a greater hysteresis curve area, hence it dissipates greater heat energy. Let us see the next question. Next question is C. A system displaying a hysteresis loop such as a ferromagnet is a device for storing memory. Explain the meaning of this statement. Let us see the answer. So answer to the problem C is the value of magnetization is memory or record of hysteresis loop cycle of magnetization. These bits of information correspond to the cycle of magnetization. Hysteresis loop can be used for storing information. Let us see the next question. What kind of ferromagnetic material is used for coating magnetic tapes in a cassette player or for building memory stores in the modern computer? Let us see the answer. So answer to D is ceramic is used for coating magnetic tapes in cassette player and for building memory stores in modern computers. Let us see the next question. The next question is E. A certain region of space is to be sealed from magnetic fields. Suggest a method. Let us see the answer. Answer for E is a certain region of space can be sealed from magnetic field if it is surrounded by soft iron ring. In such arrangements, the magnetic lines are drawn out of the region. Let us move to the next question. Rest of the questions will be discussed in the next class. So before we close this session, we request you to subscribe, like and share our YouTube channel. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for watching our YouTube channel Experience Tutor and supporting us. Thank you very much.